All right, here we go. Hello, everybody. How are we all doing? It is hump day. It is Wednesday. How are we all doing? Hopefully, everyone's all right. Got a hello? Hello there. Right, we're going to be doing some work to do with parallel and perpendicular lines. Now, the parallel part of things, we're not going to focus too much time on because the parallel part of things is actually really, really straightforward. We're going to spend a little bit more time thinking about perpendicular lines. Okay? Oh. Right, we're all good. Let's kind of get started. It might be useful for you to have some pen and paper with this one. I know I've said that for the other ones that more of a kind of show and tell kind of thing going on. But for this one, having some pen and paper will be handy because we're going to be thinking about what happens with parallel and perpendicular lines. So, first of all, we're going to just be looking at some graphs. So let's have a look at some graphs. Let's have a nice straight line first of all. So this straight line that we've got here, if we go 1 unit across, we go 2 units up, so we have a gradient of 2. Cuts through the y-axis at 1. So the equation of the straight line is just going to be y is equal to 2x plus 1. This is something that we've kind of covered in a different video, but we can still make sure that we cover it now. And if we look at the slope for that line, we can see it gives us our gradient is equal to 2. So let's take a look at another line. Let's take a look at the line 2x plus 3. Okay, we get a very similar line. We have a line which has the same gradient, okay, because the coefficient of x, the number that's in front of the x, is exactly the same. Okay, we can see that the slope on that second line is exactly the same as the slope for the first one. We just see that it cuts through the y-axis in a different place. Okay, and this sets up one of the useful bits of information that we have to deal with parallel lines. Okay, and that is that parallel lines will have the same gradients. Okay, that's what causes them to kind of go up at the same rate as one another. Okay, but what they have that's different is the different y-intercept. Okay, so that's what we have at least to start with. Parallel lines will have the same gradient, just different y-intercepts. Okay, and we can take that line and we could shift it around anywhere. Okay, so I'm going to create a little slider here so that we can see that no matter where we shift this line up or down to, it still has the same gradient. Okay, it just cuts through the y-axis in a different location, and that's what causes it to be parallel. Okay, so they will have the same gradient. The value in front of the x does not change. Okay, but they will have a different y-intercept. Okay, so a question that we could have to do with parallel lines could be find an equation for a line that is parallel to y equals 3x take away 1, but passes through a coordinate 2, 5. Okay, that could be a perfectly reasonable problem for us to have a look at involving parallel lines. And we have to think about what we know to do with parallel lines to start off with. We have to think of the thing that we've used a lot of in these last few videos, which is the equation of a straight line. Okay. Now, at this point, we're going to have to see what information we can match up and what information will be different. Well, the gradients will be the same. So I know that the value of m is going to be the same as it is in the other equation. It's just the different y-intercept. And if you remember from one of our other videos, we looked at a method for finding out what this y-intercept will be. And I'm just going to give you a little moment to see if you can remember how we find that constant at the end, that number at the end, okay? Just going to give you a little moment to think of that in your head. How did we look to find that constant? What information do we need to use in order to find that constant? Well, what we need to use is the bit of information we've not used yet, the coordinate. So, the same... I cannot write today. So the same gradient would mean that we get y equals 3x plus c. And then we use the coordinate 2, 5 to say that 5 is equal to 3 lots of 2 plus a number, or 5 is equal to 6 plus a number. Take off 6 from both sides to get c is negative 1. So our equation would be y equals 3x, take away 1. So let's actually edit this in our little program. So we've got our gradient was 3, and our first... Oh, you are kidding. Okay, so you may notice that the answer that we got at the start and at the finish is exactly the same. Okay, and that's because this line does go through that coordinate. Okay, this is what happens when you make things up on the fly. You have a chance of just making it work without realizing. Okay, this would have done what we needed to do, and it would, if this had been a point that wasn't on that line, give us a different number here. Okay, we didn't do anything wrong. It's just that this point was already on that line. Okay, if I just show you on the graphing tool here, the point 2, 5, and there we go. So yeah, here we go. We can see that at 2, 5, we already go through that line. Okay, so here. So that was a bit of a silly example, really. But we didn't do anything wrong in terms of the maths. Okay. Let's have a look at a second one. So same situation. Find equation that is parallel to y equals 2x plus 5. Okay. So we want one which is parallel to this line. Okay. And we'll say that it goes through 1, 3. Okay, and just to make the point clear. Okay. Now what you can do if is I would give you actually a couple of minutes to see if you can trace through the steps. We didn't do anything wrong here. We did exactly what we needed to. So we're gonna see if we can complete this one. Okay, I'll give you a little bit of time to just get a head start on things. So we look for the gradients, because we know that the gradients are going to be the same. And we're going to use the coordinate to find out what that extra number is. You've got just over a minute to see if you can put the two and two things together and come up with that, what that new equation is going to be. All right. So if we bring things up to here, we can see that the gradient is the same. Okay, they both have a value of 2. It's just finding out what this constant is. And we use the coordinate to find out what the value of the constant is. This is our x value. This is our y value. So when I substitute those things in, we get that 3 is equal to 2 lots of 1 plus a number. Well, 3 would be equal to 2 plus an extra 1. So that means that c has got to be equal to 1. So the equation that we end up with has got to be y is equal to 2x plus 1. Okay? And if we have a look on the graph here, there is the black line here is the line for the equation that we found out, and it goes through that point 1, 3. Okay? Exactly the same method as we did before. And this time it does give us a different number at the end. Okay? So that's parallel lines. Okay? Parallel lines will have the same gradients. They will just cross through the y-axis at a different point. Okay? Now, what we want to have a look at as well is what makes lines perpendicular to one another. Okay? Now, what I've added to our graph here is a perpendicular line. Okay? And you can see that this just will remain perpendicular no matter where on that line I go through. Okay? So it doesn't matter where it cuts through the y-axis. What matters is the gradient. Okay? So for perpendicular lines, it doesn't matter so much about the y-intercept. The y-intercept can be different. Okay. What we need to be thinking about is the gradients. Okay, so I'm going to shuffle this across into full screen. Here we are. Okay. So I've got two things here that we want to look at. Okay, we've got the red line, which has the equation y equals 2x plus 5. Okay, and we've got the blue line here, which is the line that is perpendicular to that. Okay, and at the moment, the gradient for this blue line is negative 0.5. Okay. Now, there is a special relationship between the gradient of one line and the gradient that is perpendicular to it. Okay, so if I start to alter the gradient of the red line, we can see that the gradient of the blue line changes to keep it perpendicular. Okay, and if we take those two gradients and multiply them together, we can actually see something pretty interesting happening. Okay. If one of them's positive, the other one is negative. If one of them is negative, the other one becomes positive. Okay. And if we kind of look to multiply these two things together, which is not kind of immediately an obvious thing that we should look to do, if we multiply the two gradients together, we should get something coming out over and over again. Okay. So if we multiply the gradients together, what we get is we get -1. Okay? And that is not an obvious or immediate thing to think. Okay? But it ends up actually being true. Okay? I'll bring the paper notes back in 1 second. Okay? So if we do if we do 2 times by -0.5, we would get -1. If we do 4 times -0.25, we would get -1. If I did -1 times by 1, I would get -1. Okay? We get the same thing no matter what lines we have if the lines are perpendicular to one another. Okay? And there is another way that we can say that when we multiply their gradients together, we get -1. Okay? And it involves a key word that we've used before. Okay? What we can say is that their gradients are negative reciprocals. Okay. What that is just a fancy way of us saying if we know one of the gradients, we can find the other one by taking its negative reciprocal. Okay. We're just going to have a little look at this thing to finish off, and then I'm going to ask you to go away and have a look at a few things, because this is something that we will need to get our heads around. Okay? So let's kind of reset things back to how we would want them. Okay? So the blue line and the red line are perpendicular to one another. There we go. And we have that the gradient of the red line is 2.5, for example. Okay. We can find the blue line by taking the negative reciprocal of the gradient of the red line. What that means is that, so if the gradient of one line is 2.5, so I just put m with a little 1 to say the gradient of line 1, then the gradient of the second line, m with a little 2, would be -1 over 2.5. Now, 2.5, doing its negative reciprocal like this, is not particularly clean. It might be cleaner for us to have that written as a fraction instead, because fractions are really easy to take reciprocals of. Okay? Because when we reciprocate a fraction, we just flip it upside down. Okay? And because these are negative reciprocals, that means that we can just flip it upside down and then stick a negative sign in front of it. Okay? So the gradient of the blue line, in this case, should be either written as -1 over 2.5, which is a little bit clunky, but will do the job, or -2/5. Okay? And if we bring this back into view, the gradient of the blue line, the perpendicular line, is -0.4, which is the same as -2/5. Okay? So that kind of shows that this will at least work. Okay? If we have gradients which are whole numbers, then the top way that we did it, this way, may be easier. If we have gradients which are fractions, then this might be easier. Okay? So as I said, this is a little bit of an awkward concept, but we're going to see if we can do some things with it now. Okay? Or at least be able to work out what some gradients are. Okay? So let's kind of make things a little bit simpler at the moment. Okay. So I have got a red line, and having some pen and paper here will be really useful. I've got a red line which has got a gradient of 3. Okay, so 20 seconds. What would be the gradient of the line that is perpendicular to that red line? Okay, so if our first gradient is just 3, then our second gradient is going to be the negative reciprocal of that. It's going to be -1 over 3, which is reasonable enough to write. That's fine. And if we shuffle this across, we have -0.33, which is the same as -1/3. Okay, it's all good for us. I'm assuming that I can't write those numbers as actual fractions. That would be helpful, but never mind. No, doesn't look like it. Okay. Let's go for another one. What if the gradient of my red line was -4? Okay, so give you 30 seconds, not 3 minutes, 30 seconds. What would my gradient be for the line that is perpendicular to this line? So the negative reciprocal of -4 would be -1 over -4. Now, when we do a negative divided by a negative, we end up with something positive. So we can actually write this as just 1/4. Okay. And sure enough, if we scroll this across, just to reveal the answer, the line that is perpendicular to our red line has a gradient which is 0.25, which is 1/4. Okay. So there are some key things that we are looking to take away from for today. Okay. The first of which is that parallel lines have the same gradients and they could have different y-intercepts. Okay. And the way that we find those y-intercepts is by looking at the different coordinate that it needs to pass through. Okay. And we had a couple of goes at that. And then we turned our attention to perpendicular lines, which say that the y-intercepts can be different, and the gradients, when they multiply together, should get -1, or we can say that their gradients are negative reciprocals. Okay? If the gradient is a whole number, we can just write -1 divided by that whole number, like we did here. If the gradient is a fraction, then we can just reciprocate the fraction, so flip it upside down, and then stick a negative in front of it. Okay. Now, just from there is enough of a kind of idea for us to kind of at least take that away for a moment and have a think about that. Next thing that we will look at is sort of combining those two problems, where we will have a line that we want to find that's perpendicular, but also have it go through a particular point. Okay. Now, if I just show you this, here we are. Cool. Now, hopefully this will come up on your screen as well. Excellent. What we've done today, you would be able to do any of the stuff that's in this exercise up to question 5. Okay. So finding equations of lines which are parallel to these. Okay, we can just have a same gradient, different y-intercept. Finding an equation which passes through a line and a particular point. Doing the same thing but graphically, so you'll need to be able to find out what the equation is by looking at the graph. And similar kind of thing going on in question 4. Okay. And what we're going to be looking at in our next video, when that will be, I can't remember, is the kinds of problems that would feature in the later parts of these of this exercise. Okay. On Corbett Maths, if I show you my screen for a second, you can find this that exercise by going to corbettmaths.com/contents, and then you're looking for linear graphs, parallel lines. Okay, and it's that one there. Okay, and it might be worth you spending 5 or 10 minutes having a go at some of those earlier questions, so then you can see what they do. So there you go. That's the one that you want there. Okay, the web address is just up there. Okay. So I guess that really the only thing left for me to ask is that is there anything that anyone would like to see again or try another question of or anything like that, whilst we're kind of still ticking over? The silence is deafening. All right. Anyway, what I'll do then is I'll kind of leave it up to you at this point to go and try some things out for yourselves. If something flashes up in the next few minutes or so, saying can you just go over that one more time, then I will do. Other than that, we'll kind of draw this one to a close at this point. Okay. As always, if you want to email to ask a question or ask for some advice or some help, feel free to do so. And yeah, I would basically really recommend you having a go at the exercise that I showed up on screen before. Okay, and if you want to, you can just, press pause at this point and have a go at some of those questions right now. Okay. If you want the answers to these, you'd have to go onto the website and find the answers, or at the very bottom of this exercise will be that there, which you can click, and it'll take you through to the answers as well. Okay. But yeah, I will leave you to have a go at some of these. Feel free to message me via email if you want some help, or if you just want something clarified. If not, I will see you in the next one. We're good. Okay, excellent. Just seen some messages click through saying we're good. So we will leave it at that, and I will stop rambling. I will see you next time.